Yeah, so today I'm going to try to do a better job at explaining objects and go a little bit deeper into it. So this will be new for Kurt, and I'll probably tell everybody not to even bother watching last lesson. Sorry for wasting all your time.
I didn't think it was that bad.
No, I didn't think it was that bad either.
I did. So I'm going to try to make it up to you. So the first half we'll go through a little bit quicker because we've kind of gone through a lot of the kind of text. So it's going to be a kind of recap for most of you except for Kurt. But yeah, hopefully it kind of is a little bit better structured and easier to follow. And hey, repetition makes learning. Woo!
Oh, there it goes. It just escaped the learning.
So yeah, we're going to talk about objects again, and try not to fuck it up this time. So, are you gonna miss class again, Kurt?
Are you getting water?
No, I'm getting water. Who else wants water?
I'm good.
So,
Please.
well, I feel like I should probably wait for Kurt to show back up because he's gonna be kind of lost. So let's all watch Kurt get some water.
There you go.
This feels like a really boring reality TV show.
Yeah.
I'm just really excited. This is like recording. This is like if somebody just like randomly swings by. This is like the first 5 minutes. Yes, class looks like a lavatory.
Yeah.
Hydration's important, guys.
It is important. Thank you.
Bet. You don't want to pass out in the middle of class.
And it's hot here. It's hot.
Yeah, global
It's all
warming.
hot. Global warming.
Hot here too. Noted.
Nice.
Nice. Good hydration.
Yeah, so back to the slideshare. Yeah, so we've talked about this a little bit. Data in Python and basically in every computer language has types. Type is basically like a format, and kind of it's hard for me to explain because like or just a kind of it's hard for me not to just be like, well, a type is like a type. But yeah, so you've talked about integers. So we might have a variable and it's got like an integer in it. And we might have a variable that's got a floating point number in it, or a variable that might have a string in it. And so each of these is an example of data that has a certain type. We have list is another type. It's kind of a compound type. It's a type that stores other types of data in a list. It's kind of handy. The reason that we have types in computer programming is because ultimately everything on the computer is just a bunch of ones and zeros. And types let us kind of work with variables like in a way that actually makes is sensible. So I've got like a little example here. We've got our variables that we set up, and so yeah, it makes sense. We can take integers and we can add other integers to them. That makes a bunch of sense. My integer was 48. We added 2, and we got 50. Awesome. That's how addition works.
Could you add a float to an integer?
I just asked that.
I'm about to go. Like, let's say if we went ahead and tried to take a float and divide it by a string.
No.
Yeah, that doesn't make sense. What on earth is 5.2 divided by graham cracker?
I like it. I like it, but it doesn't do that.
Python doesn't. So Python will throw back a type error. Unsupported operand. So an operand is like an operator, like plus, minus, divide, equals, like. That's what we call. So if you see operand, it means like unsupported operand types for divide or slash here. So it's like, hey, my division operator does not support these two types together. I cannot take a float and divide it by a string. So I'm going to actually pull up some Python because you guys were asking, can you take an integer and add it to a float? That is almost certainly possible. Because yeah, that kind of makes sense that there is going to be some interoperability between, let's go, integer equals 48. My float equals 5.2. So my integer, that's my float. So we got 53.2. And so it's got a decimal point, so it made a float. So basically, like the plus operator for integers and floats knows that, like, hey, plus is like, oh, I can operate on things, and we could actually take strings and use the plus operator and combine two strings together. So plus kind of knows it works with different data types, and it's able to say, oh, well, I do know how to add an integer and a float together, and it's always going to give me another float because, like, in case I need a decimal point for the floating part or the float part that I put in.
So it inherits the float characteristic instead of dropping it off.
So we can, like, take my string plus my string. We get graham cracker. But if we try to go my string plus my float,
No way.
so plus is also known as concatenate when it's involved with a string.
Now, can you add a string onto a list?
I can try. Let me see real quick. So I'm kind of curious because right now it said cannot concatenate, so it was using like the string version of plus. So I want to see if we go backwards a bit. Yeah, so that's interesting. So if we swapped the order, if we started with my string plus my float, it was using the concatenate version, which is concatenate means stick two strings together, glue them together. Versus when we started with the float, we're saying, okay, add string to the float, and it's saying, okay, I'm using the addition operator for the float, and it's saying, okay, I can't add a string to a float. Let's make my list.
So in this case, then, my brain tells me that if I start with my list plus my string, it can add it together. But if I do my string plus my list, it won't work.
Well, let's see. I'm not super sure about. I think it's not gonna like this, but I don't know yet. Yeah. So it can only.
You can't do it either way.
So you need a string or my float. Yeah, so lists can only add them. You can only add a list to a list because I think it doesn't exactly know what it can do. It's like, for instance, strings are technically like a list of letters.
Right.
So it probably wouldn't be sure whether or not you want olives, sausage, or then G, then A, or olives and sausage and graham cracker. So like with lists, we have like
interesting snack.
we can do list.add. String. Oh, never mind. No, I can't do that. I lied. So, yeah. So we have these data types, and sometimes they're kind of interoperable, like depending on if it's been written to work that way. But it basically like protects us and makes sure that the operations that we're telling the computer to do, like the computer knows how to do them. That they're sensible. Like the computer has
make sure the data is compatible.
Yeah, the computer has no idea how to take a floating point number and divide it by a string. It's just as confused as you by 5.2 divided by graham cracker.
Yeah, but it probably doesn't laugh when it thinks about 5.2 and plus graham cracker.
It might let out a chortle. We don't know that. They will. So
I want to sidebar a little bit because a lot of you, I think, are probably going to go into Python or Arduino or maybe C# with some Unity stuff. So Python and JavaScript, actually. I'm just going to type this. It's going to scrap my thing. So Python is what's known as a dynamically typed language, which means that variables can store anything. They still have like types. Like 3 is still going to be an integer. Butter is still going to be a string. But when you put 3 into my variable is like, okay, I have an integer in me. And when you put butter into my variable, it's like, oh, I have a string in me now. And yeah, Python doesn't care what you stick into its variables. I can kind of, so we go, my variable equals 3, and my variable, hey, it's got 3 in it, equals butter. It's got butter in it now. It doesn't care. It's just like, hey, I have variables and they store data. When there's data in them, they have like whatever type the data is. But that contrasts with what's known as static typing. You'll see this in processing or Arduino, where basically variables have to have, like when you create the variable, you tell it that this variable is only for storing integers or only for storing strings. And you do that when you create the variable at the very start. So like if I were writing in like C++, I'd be like int for integer, my variable equals 3, semicolon. Then if I wanted to be like my variable equals butter, if I want to take butter and stick it into my variable, C++ is going to be like, no, you can't.
But you could put, what, str on the front of my variable and have butter be a string and have the variable, my variable, be a string?
If I set up my variable to be a string, basically with Java, processing, C++, Arduino, any statically typed languages, when you create the variable, you have to say, so like kind of the variables are boxes for data metaphor. In C++ or Java, like the boxes will only fit a certain shape of data. So it'll only fit it. You can only stick an integer in this box. You can only stick in that. And like when you create the box to begin with, you have to, like that sets it and that can't be changed later.
So if you had an integer, so 3, and you wanted to put it into a float, you'd have to write it as 3.0.
Probably.
To have it accepted.
A lot of languages will do, especially with integers and floats, will do automatic conversion. So like if you could be like float, my variable equals 3, and it, like, well, 3 can also be.
And then it would put
float.
it out, if it said float, you would put it out. When you did the thing and it was showing you what my variable was, it would print it out as a 3.0.
Yeah, possibly.
Right.
But yeah, so kind of this is important, just like in general. I don't know, if I teach this class again, I'm probably going to switch it all over to processing, because I think if you're doing stuff like this, where you've got a variable and you're sticking different types of data into it at different points in time, you're doing something wrong.
Right, it's messy.
Like, yeah, you probably should have just, I mean, variables are free. So you probably should have like a separate variable that stores your string and a variable that stores your integer. I don't know, there are some times when like having dynamic variables is like convenient, makes things a little bit easier. Like for some reason, if you're like sorting through data that has different types, you can do weird stuff with it. But in general, like ask yourself, why you're not just using separate datas or separate variables for separate types of variable. So that's just kind of a sidebar discussion that you'll run into if you start using processing or something that, you just have to, and, it just builds awareness of like, hey, variables, the data in them has a type, and like that variable respects that.
So a sidebar question. Arduino is a language.
So Arduino is a platform. It's programmed in, it has its own little development environment, but that development environment, you're writing C in it.
You're writing C.
Yeah, or C and C++. Similarly, like, yeah, processing is kind of like it's Java with some graphics libraries on it. So, but yeah, so data is great. You can do a lot with data. So we kind of built these built-in types into Python, integers, floats, strings, lists. Lets you, so these all kind of carry single units of data. Strings kind of a special case because it carries actually a bunch of letters. Lists carry multiple units of data. You can stick in multiple strings or multiple integers or even mix strings and integers and stuff around. But what if we want more? This is kind of what we were talking about last time. So like all of these things are great for holding like a single unit or like a single list. But we can create our own types for data. So let's say we were building like a donor database or like working with a bunch of donors for a nonprofit organization or something. Hypothetical example here.
Yeah, totally hypothetical.
And what if we wanted to like work with like records for an individual donor? Might have a name, how much they've ever donated, an address, phone number, like a bunch like so. Some strings, some floating point numbers, some integers, maybe a list or two. But we all want those different chunks of data to all be related because one donor has a name, and a phone number and an address, and we want to keep all that together in one little package. So we can create a custom type, maybe called like a donor type. And so we can create variables like my donor that are of this donor type and like have a name field and have a donation total field and other things. So basically we're going to be we'd want to create a donor class. We talked about classes, and so that's going to be like kind of this big box, and inside it, it's got smaller boxes for like for name, donation total, whatever. So you've got this donor, and it has kind of like sub-variables, which are known as member variables. And so this class is like, and I'll use this metaphor a little bit later, it's like a cookie cutter. It's like a blueprint. It kind of like says, okay, we're going to make some donors, and they're going to have these fields. Like they're going to store this data, or this type of data. So we use it to make objects. So we'd have our donor1 like variable, and it would have, so donor1 would be an object of the donor class. You would have a name, maybe Susan, and a donation total. And we might set up donor2, with a name and a donation total, donor3. And so that might actually look like donor1.name is Susan, donor1.donation total is 58. So we're creating these variables that are of type donor, and then they have these like subdata, this object data that, so donor1 has a name that belongs to donor1, it's Susan. It's got a donation total that belongs to donor1, the 58.
Can you go back a slide?
So these are sort of like sets? Okay, you created this class, and it gets a set of data stuck into it, and that creates the object. The object is a specified, individualized, specific piece of data that's under the type.
Yeah,
under the class. Is that right? Did I get this right?
More or less, yeah.
Oh, okay.
That makes sense.
What are you guys laughing about?
Specialized specifics. There was like one more in there.
Oh, sorry.
I was just like, whoosh.
Yeah, so the idea is that like the class is like the pattern, like how, what sort of like, what data do these objects hold? Like,
so in this instance, donor1, donor2, and donor3 are
the result.
These are the objects.
Those are objects within the class donor.
Yeah. And so this is the donor class. I'm actually going to move this out.
So is it right to say that the objects are the results of the pattern that is the class?
Yeah.
No, it seems. I just sort of see it as like it's like you have all these little drawers in the big
in the cabinet.
in
Right.
the cabinet.
That's right.
Okay, that I understand. Right, so you have
So
a
the
cabinet.
cabinet is the class.
The cabinet is class, yes, and
Okay.
then all the little drawers are all the little things that go in that cabinet.
What are the drawers called?
The drawers are the objects.
I'm gonna actually draw a cabinet.
Yeah.
That's how much I like
So
that.
if your
the
cabinet-
programmer is the cabinet maker.
Oh, yeah.
We're making progress here.
So if this is like your
Oh,
I don't know if this is a very
oh,
accurate example, just because like that would imply that the class is containing these objects versus like the class is like a cookie cutter that basically says, hey, say these objects
be
have this
this way.
shape.
This way, right? Okay.
Oh, class
Yeah.
is like
Yeah.
So like the class defines the type. So like actually, so like all the types that we were talking about earlier, they're actually like classes and object. They're actually classes. So like the integer class, like it has one data member and it's just integers and whatever behaviors the integers do.
Mhm.
So like the string class is like, hey, I exist and I have this like list of characters. And I can do certain things to them. I can add together and stuff. So like we've got this donor class that says it's like kind of a cookie cutter, and then we create objects that are like stamping out. So like cookie cutter to cookie. Like the cookie cutter defines the shape of the objects that we'll make, and the actual cookies, like they might be a little different. We might decorate them differently, but they'll have the same overall shape and cookiness.
So it's sort of like a glass. We talk about a glass as a type. And then there's a whole bunch of different kinds of glasses. So those are the different objects.
So
Because they use
Yeah.
different variables in there.
yeah, so if you're like the class would be like glasses
Right.
in general, like short glasses, tall glasses, whatever, and then the objects, would be an object would be an individual glass, and so like it might have like a height data, it might have a width and a volume and a shape.
I mean, I see it as just the way how we classify and organize anything scientifically,
Yeah,
like animals and
so-
you have
Animals make sense. Yeah.
like you have your
Mhm.
mammals,
Yeah.
reptiles, whatever, and then within reptiles you have it's split up into
so it might have like a dog class and an individual, so that that would just describe like, okay, what is a dog?
Yeah.
Like it has 4 legs, a
It's
tail.
an animal.
descendant
yeah.
of a wolf, whatever.
It probably has a name, but like the generalized dog class, like we don't know any of those specifics. We don't know like, we can make, we know that a dog has a color. We know that it probably has a name. We know that it has things that it likes. And so so it's kind of like a blank template for like, okay, dogs have these like qualities to them. And those qualities in the class are just empty. The actual objects are where we fill that information out. So like an individual
Whether it's a green
dog,
dog
has,
or a
like,
blue
okay, it
dog
has a
or
specific name, Fido or
Look, there's the
Maxwell.
cookie cutter thing. Yay!
Yeah,
I about that.
Yeah.
yeah. It's hard to kind of totally describe because like they're similar, but like they vary. It's like one's kind of like meta level. But yeah, and so we wind up with having these, individual donor 1, donor 2, and they have, these member variables that hold data. Like donor 1's name is Susan, donor 2's name is Yuki, and so yeah, it like sets up this pattern so we can easily work through, process things on, if we needed to have a function that added money to their donation total. It could take in a donor object, like a generic donor object, and add to that whatever donor object's donation total. So we wouldn't have to know the specific donor to create the function. I don't know if that helped. But yeah, so in order to actually make classes, basically the pattern is we use the class keyword, give it a name, and then yield colon. Then in Python we create this constructor function within the class. It's got a special name, underscore init underscore parenthesis self colon. And then under that we do use this self dot whatever variable name we want to do, and this kind of gives us data field names. So like in our donor class, so donors have a name and they have a donation total variable. So every donor that we make will have a variable for name and a variable for donation total. So
Wait, so you have to do self? Wait, I'm confused. So to make a class, you do that, and then you... So is the self thing already in there, or is that something you put in there?
that's something you have to type in. The self
Okay.
thing says that object will have its own copy of this variable.
Oh.
So when we say
Okay.
like self dot like donor1 dot name, like that's how it links that to donor1 specifically, and not
And this is just a Python thing.
This is just a Python. This is another reason I'm like not liking Python right now. It's not this convoluted in other languages.
Okay, got it. So we have to do self.name and then give name. How does it link back to How does it like go link back to donor?
So
Creating it.
yeah, when we
Okay.
so this init function, this is the function that tells like when you want to actually make a donor, this is the function that runs, and it sets up the actual object. So that's why they call it a constructor function. It's actually like setting aside memory on the computer to like store all of these variables and set up this object. And so if we want to give it, if we want to give our objects variables, we have the self dot whatever variable name, and we have to give it like a initial value. So for strings, it makes sense for it to be an empty string. For integers, I'm at 0, usually a pretty good choice. You can't have like defaults. Trying to think of a good example right now. It might not always make sense for this to be 0. You might have like we'll talk about this later. You might want to set up a color, and maybe you want your color to automatically start at 255, 255, 255 instead of so it would start as white instead of start as black or something. And then if you want to actually create objects from, so your class is like setting up a pattern, like what does a donor look like?
What are the objects going to be in donor? Is that basically what it is?
Yeah.
Okay. So you're defining what those objects are going to be in connection to that class.
Yes, the class like sets up what an object, like what properties an object has.
Yeah. And those are going to be the.
Yeah, and that's this like
That's all that
self.name,
stuff.
self. So
Self-done.
any object we create, any
That's
donor
myself.
object that we create will have a name and will have a donation total. In order to actually create an object, we actually invoke the constructor with the class name and parentheses. This is calling that class as a function, basically. And that actually calls this init function. So we kind of set up like a variable, my donor, and we're going to actually make a donor and stick it in there. And so now we have like this donor, my donor. It's got a name that we can like as a variable that we can stick a name in. It's got a total donated that we can stick a value in. So and actually
Make one. It's the only way I can figure it out.
I'm just deleting these so I can
So I'm going
copy paste way easier.
Class, whatever. I'm going to make a pony class
Do it. These are
right
awesome.
now.
Sure.
And so then I have to do the def blah blah, and it.
Got our donor class, and then it can be like, my donor is, so my donor, just a name, so it could be anything right now. So we're going to actually make a donor in it. Then it's my donor. So we can actually see, like, okay, it has a name variable already attached to it. It's blank right now because it was blank when we created it. Kind of the donation total. But yeah, so now we have those. We can actually.
If you want a object to be a list, what do you do? Put quotes and then what? Little brackets.
Just bracket.
Bracket.
Empty list would be like that.
Bracket.
A 0. So. Yeah, so I'm going to use another example that's going to be more useful to us art types. It's So we have like a color class, and I'm actually probably going to use this with the homework I put on this, because this will be really convenient for Turtle. This will integrate well with that. But create a color class that would have a G, a red, a green, and a blue like data member to it. So that way we could have like colors that we could, instead of having to be like, okay, well here's, if I want to have 5 different colors, instead of having to store all of their R, G, and B values like separately and create like 15 variables, I could just create 5 of these color variables, each of which store an R, a G, and a B channel. Just making sense?
Mm-hmm.
So far, all we've been using objects for is a way to like store compound data, to store groups of data in a single variable, in a single object. A lot of the power in objects and classes comes that you can also give classes their own functions. So kind of we've been using this a little bit. So objects are nouns, so data as nouns, and functions are verbs. So like our my donor variable, our data here, like that's a noun. A donor is a donor. A color is a color. So what if we had a color? What if we wanted to create something that like actually inverted the color? So the way we do that with colors that go from 0 to 255 is just take every channel and subtract that from 255. So we could write this function that would take in a color object that we're going to call color. And so since we know that colors, since we set them up here, have this .r, .g, .b. In our function, we can be like color.r, color.g, color.b. So I've got color somewhere. You can ignore the text of this slide for now. So
we just made a color, or a class color, and it's got red, green, and blue.
some of this create a color that's my red. Make the R channel at 100. Make the G channel at 10. B channel at 5. Go my white equals color. My white R equals, let's make it slightly off white. So let's go to 240.
Wait, otherwise.
255, 255, 255. So now we have these two colors. We can write this function, paste this function, f invert color. Oh, fuck you. Oh,
Damn, you have to put an extra.
just in the colon.
Always getting that error.
So now that we have my red, so that exists, we can actually even see what the R, G, and B values are. We could go inverted white equal to invert color my white. Now, so that went through this and took in the original white that we had for my white, then changed all the colors and spit back a new color that we put in, that we stuck into my inverted white. So I can see, hey, the R is 15, the G is 15, going to be a 0. So it's going to be already almost black from what was an almost white. Similarly, we could do the same thing with.
But where's the line that tells you to invert it?
So I did
Where
this.
did it
My
go?
inverted white was.
Oh, and
Invert color.
my inverted white is already
I just
Find
function.
up above.
it's above. It's just,
I just made a new variable that since we returned a color object from this, it got stuck into this new variable.
and it just knows that it just knows to invert it.
So
I'm like a little lost.
so we called this function invert color.
Okay, so
On my
invert
way.
color is already a function that's been created somewhere.
Yeah, so I created
okay, it's up
that
there.
right here.
Oh, God. Okay. Sorry. Got it.
So I created this function that takes in a color and returns the opposite color, basically.
Yeah, I see.
So I fed it in my white and basically got a black. I can do the same with like the red I had. So that's mostly a bluish green white now. So that's one way we can create these like functions that just exist in the world that take in whole objects, do something to the objects, and then return something or print something or do whatever. So we can pass our own custom objects into functions that we write. We can also build in these functions into the objects themselves. So like we have this init function that set up our object within our class color. We could also create an invert function, which would take the color and just in place, just turn it from a white to a black. Do the same 255 minus the color channel value.
But you have to know all the RGB number range. Which you'd think I would know by now, but I don't.
That would be the easy part for me. The rest of this.
So yeah, now I just redefined our color class, and so now we can create colors, and they'll have an RGB value attached to them, and we can also automatically invert them. So let's go ahead and create a new my blue. My blue dot R, just like this. Very simple. So 00255 is just straight blue. Now what we can do is my blue dot invert. We can check out what's an R? 255 now. G 255, B0. So that went ahead and my blue. So if you want to, functions they have to have, if you're creating a function, they have like function name, and the first argument you pass into it has to be self, again, so it kind of knows it's working on itself. But yeah, so it went ahead and instead of having a separate function that we wrote that like did this operation on a color, that took in a color, spit out a color. This one basically says, color now knows how to invert itself. So it'll take the data that it has inside it already and change that data.
Mm-hmm.
So we went from, so my black equals color. I'll just kind of show, since we start off at 0, 0, 0, my black dot R is 0, my black dot G is 0, my black dot B is 0. Run the invert function that it now has. We get 255, 255, 255. It's now totally flipped. It's a white now. So yeah, this is the exact example. So this kind of brings us, so, in this here, there's two functions here. We have our constructor function and we have our actual object function. We can do some extra stuff to the construction function as well. We can actually add, so the constructor function is responsible for actually creating the objects that we want to use. I'll move back to the slide. So it's what, when we say set up a variable and we want that variable to have a color in it, we call this color function, and that calls this initself function on this class color. And it sets up my color to have my color.r, my color.g, my color.b, with all those values being 0. We can actually add in, so what used to be initself, we can now be initself, maybe red, green, and blue.
Yeah, no way. This is not. I'm not kidding this. No. The whole self thing is because that self.r, that really is my color.
So that's saying,
That's it,
every object will have its own copy of an R.
Okay.
And will have its own G and its own B.
Okay.
So it's just saying that how we just make sure that, again, that's kind of why I should switch to.
Probably because of the Python thing.
Yeah. So whenever you see self, it's there for complicated reasons. You can basically ignore it. It's just a pattern.
But self is a function, is a little function signifier in Python.
Yeah, it's a keyword that is how Python kind of keep track to okay,
track of
how do
these
things if we're writing code within our class, make sure that we're talking about something that just belongs to every instance of the object, as opposed to some other R variable that might exist somewhere else.
Oh, I see.
Yeah, so self would be equivalent to my R.
Yeah, that's what I was. Yeah.
Yeah.
So I guess that's why.
So init would be me, and my R, my G, my B. You don't see it in other languages. It's much more optional in other languages, I guess. You will see it sometimes. But yeah, so we could actually redefine our init from just self. We could actually add a red, a green, and a blue variable that would then populate our R, G, and B. So now we can, instead of being color, parenthesis, when we want to create a color, it'd be color,
And then numbers.
R, G, B. So we can actually, when we create our colors, we set them up with existing
So that the
values.
first ones are the second one, so those numbers.
Yeah,
correlate
so
to
this
R.
would be 100 would fit into R, which would then, in this
Yes.
function, get chunked into myColor.R. 0 would
Gotcha.
be green, get chunked into
So this
myColor.G.
just saves writing 3 extra lines.
Yeah, so instead of having to be okay,
Yes,
my
all that.
myColor.R equals 100, myColor.G equals 0, instead of having to create our variable or our object and then populate the fields within that object, we can just create it all at once. And yeah, you'll see this way more often than this pattern. So yeah, if you have objects that when you create them, they should probably have data that you give them, color, unless you would want to always, yeah. So this is saying create a color and that color is always black, and then change it after you've created it, versus this hey, create an arbitrary color given a red, a green,
Yes.
and a blue value.
Got it.
So I just duplicated the slides.
I wish this class was poolside.
So I'm obviously losing Jenny, which is good because we're about to kind of wrap things up here.
Oh gosh.
Or like on a patio at the bar.
Yeah, exactly. I think I'm
Drink
ready
some
for-
wine together, all of us.
So the last thing I want to talk about is there is what if we want to have, we've got our custom classes, what if we want to print them? So if I were just to go, it's got my black that exists, it's technically a white now. You go print my black. Well, it's going to tell me it exists like within the main scope. And it's a color, it's an instance of a color class. And it exists at this memory location. Which, like, is nice to know that it exists, but doesn't help me a lot. If I was, like, debugging, I can be like, oh, I have a color and it exists, great. But I don't know, like, what's actually in it. Like, in this case, my black contains a white right now, which kind of confusing. I might want to know. I might want to be able to figure out how to see inside my black. Python classes. So init is this special function for creating our class. __ repr that's actually how Python prints things. So let me see if I have a slide way back up here that talks about. I don't think I recorded that slide. Everything in Python is an object. So like integers are an object, strings are an object, lists are an object. And they all, the way, if I go, so my string exists, so I want to go print my string and print it out. The way that actually works is that print says, hey, string object, do you have this repr function that I can use? So if we want to have objects that actually print sensible data, or like human readable things, we have to set up this repr self function. It's baked into Python, like it's a special like keyword that Python will know how to, that print specifically knows how to use. And importantly, we have to return a string from it in order for print to actually use that. So like here in color, all we have is integers, most likely. We have our red or green or blue integer. So in order to get a string, we actually have to use this str function to turn our self.r, our self.g, our self.b into strings. So we're going to kind of make this substring s. So we're going to have this function repr that we're going to use to print stuff. It has to return a string. We're going to call that string s. We're going to do this. Let me actually write this down. I finished, or I got done with these slides at like 5:59. So.
Well, you'll be glad to know that I did not get my grades in time for summer school, so now I'm on the shit list. I just didn't realize we had to get them in so quick.
Oh yeah, quite a turnaround, man.
Yeah, usually I have like a good 5 days or something.
Oh, it was less than that.
Yeah, just like 2.
You got like a week or something.
Yeah, that's why I didn't get. So I was like, what? They were due on like Tuesday. Classes just got over on Friday.
Oh my gosh.
Yeah. So what's gonna happen? We're gonna set up this string to print variable, and it's gonna have r : plus whatever our r value is in our object, converted into a string using this str function. Again, it's a special built-in function that, and you can actually write your object to have a function that that str will be able to do things with. Kind of a little inception thing going on there. But str will turn like integers and floats into strings, so you can add them together with the plus sign. So this will be r. Will give us r : plus whatever the value is of our object's r value. Then I'll add to that comma g : and comma b : so we'll actually be able to see what our colors are. that. And white. Let's make a new white. 255, 255, 255. You go print. White. I guess it's actually like readable shit
Oh,
Hmm.
look at that.
instead of
That.
main.color instance at
Is it
0x.
blah, blah, blah,
Yeah.
blah.
It's kind of a fancy optional thing. But just kind of another example of classes can have object or have functions in them that then objects get to use. So,
Oh no. Oh, that's next week. Thank goodness.
yeah. So we're pretty much wrapped up today. Let's stick around and answer questions. Next week we're going to talk about polymorphism. Is there anything you guys want to talk to? Like, we've got 2 classes left.
I don't know what there would be to talk. I mean, I don't have any context
Yeah.
as to like what would be next.
So I mean, this class so far has covered kind of the basic, like, fundamental concepts in computer science in terms of working with data and functions and objects and recursion and iteration.
I'd like a follow-up of like all the. I want like a lecture that now ties all those things together. That makes sense.
I probably need help putting it together. I mean, I don't know what exactly that would look like. I'd be happy to do it.
Or just like somehow so I can see the whole thing. Or maybe just a review. Whatever.
Sure.
Just a review of like, okay. Because I almost feel like now the stuff in the beginning is gonna make more sense to me.
Sure.
Because I have more context as to what the heck is going on.
Yeah. Yeah.
Of course, if I actually didn't need any of the homework, I'd probably have a much better idea of what's going on.
I told you at the start.
I know.
I'm to the point where I don't even know where I go to attempt the homework. I just,
Is there anything you're interested in learning, Lauren?
Yeah, I feel kind of the same. I don't really have a context to ask a question in.
I mean, I think that makes a lot of sense. I mean, the kind of purpose of this course is like kind of conceptual framework underlying a lot of this stuff, as opposed to like kind of specific tools, techniques to actually do things. So, kind of designed to dovetail with, you know, other experience and or projects that you're working on, kind of like, you know, this is kind of a formal knowledge side versus kind of an experiential, like I'm going to go on Instructables and then go on YouTube and learn how to do things. That way, like, pick up bits and pieces of people's code on the internet, kind of use those, kind of like, that'll like raise you up to a certain point, and then kind of the fundamentals kind of matches that to let you kind of get past the breaking points.
Yeah.
So.
Yeah, I feel like I have a better understanding of what I was trying to do when I was building the costume at Laboratory, and what I need now to make it better. So
Cool.
I feel like I have a better understanding of what to even ask in that context. But to take that further, I'd have to try doing it as well.
Yeah, absolutely. Yeah, it's definitely programming is something that having programming to do, having a problem to solve, like really. I mean, yeah, these are all, you know, basically showing you guys a tool shed full of things that, you know, if you don't have any gardening to do, you're like, okay, well, it's another thing that cuts things, like, cool.
Yeah.
I think I'm excited to have these slides and stuff for as I do more coding to refer back to. I think that's where the big E is going to be for me. Right now, I don't know where to begin, but I think, yeah, I can build on it bit by bit.
So what's homework going to be like this week?
Homework's probably going to be working around probably creating a color class and creating more things in that. So it's like working with Turtle, creating a color class that'll let you like add color to your drawings in a like sensible way.
Okay.
So like, you know, we wrote I kind of showed you guys the invert function. I'll probably ask you guys to make a couple of different other functions, you know, maybe like a function that takes a color and makes it brighter, and maybe a function that makes it darker. Yeah, things that you can do with colors. So, yeah, maybe make a complementary color, depending on how much math you want to do.
That's my weakness.
So, yeah, I'll probably try to get homework out Thursday or Friday. The last homework, I think, is probably useful homework to do.
So I did half of it. I got to the point where I was trying to do loops, and I just couldn't figure it out. Couldn't remember how to do the command, the commands to get it. I don't know. I just couldn't do it. I have to go back and kind of look at.
Yeah, I'm always happy to help out individually, re-explain things, or help explain in different ways, and help you guys through stuff. But I mean, I think especially like the last problem set was really about like functions are programming is data and functions, and so it's like information doing shit with that information.
Yeah. And then,
so having a firm like. My goal is for you guys to have, like firm understandings of, those things on kind of both conceptual and at least like slightly practical level with Python. Just being able to know what they are and have done them at least a little bit. So that's why the programming or the assignment last time was like, hey, do 5 functions this way, do 5 of these things. Just kind of get some practice, get comfortable with what you're doing. So probably. This homework will be pretty light, kind of an extension of turtle stuff, because it seems to be fun.
Yeah, the turtle stuff I like a lot, because I can actually, there's like some sort of tangible result.
Yeah.
My kid likes it too.
It's good.
Yeah.
Alrighty. Well, if you have anything else, let me know.
So, lab's still on at 7:30 on Friday?
Yep.